All right, guys, I want to go over another day here of hyperbolas. Before we start, wanted to just remind you we have those two different forms. One where the x's come first here, one where the y's come first. Other than that, they're both subtraction in the middle, and of course, they both equal 1. All right. A couple of other things to note is also when the x's come first, our equation for the asymptotes is going to have the b over a for the slope, if you will, and a over b for when the y's come first. And then lastly, instead of a minus b, a squared minus b squared equals c squared, like we have ellipses, this is a squared plus b squared equals c squared to find our c. One way to think about that is the c value has to be the largest. Okay, and then we didn't talk about this on our last time, I guess, but ellipses and hyperbolas both have eccentricity, okay, which means that it kind of determines their shape, right? So we're going to use the formula E equals C over A. So whenever you get a fraction or even a decimal sometimes, for example, if it said E equals 0.5, you could say that's 1/2. So then your C would be 1 and your A would be 2. All right, so we'll have to keep that in mind as we do a few of these problems. Let's try them though. Let's start out here with this one. This is write an equation of a hyperbola that meets each set of conditions. And first we have the vertices. The vertices are at 2, -1, and 2, 5. And then one focus is at 2, -3. So let's go ahead and graph those things. 2, -1, and 2, 5 would be here and here. And it says one focus is at 2, -3. So 2 and then -3. All right, so what did it do for us? Well, let me change the color of the focus. First off, that focus is 2 units away. So up here, I could do another 2 units away. And then in the middle of all that, I could put a center, right? So if I count 1, 2, 3, 1, 2, 3 from my vertices there, that's going to be the center. So this does a few things. It tells us a little bit of information. First off, it says that the vertices, our A value, is going to be 3. That's 3 away from the center. The other thing it does is the focus, right, or the foci are going to be 5 distance away. And that's our C value. So C equals 5. We also figure out the center from this. Our center is going to be 2, 2. I'm going to jot that down. Center is 2, 2. That's our H and our K values. And if you remember back to our formula, all we really need now is our B. Okay, so to figure that out, we're going to use our equation A squared plus B squared equals C squared, where A squared is going to be 9, B squared, still don't know, C squared is 25. So if I subtract 9 on both sides, that gives me B squared equals 16. And really, I don't even need B. B would be 4, but I don't need it because our equation only uses A squared and B squared. Now, the other thing I do have to kind of consider is these are all lined up on our transverse axis, if you will. With ellipses, it was called the major axis, but this is the transverse axis, where it goes through the foci and our vertices. And that is going to indicate that the y's will come first, right? If I were to end up graphing this thing, it would look like that, where it kind of makes that y shape, right? So that's how you can remember that. Okay, so if that's true, then the y's will come first, and we can go ahead and write down our equation, which would be y minus our k, which in our case is 2, getting that from right there, y minus the k, over a squared. A squared is, where did a go? A squared is 9, minus, since it's a hyperbola, that's a minus, x minus my h, which is x minus 2, over b squared. B squared is 16 equals 1. Okay, again, this does not have to be where our a is bigger, right? Just like ellipses. Ellipses, the A had to be the biggest, and so that's how we determined which one went first, since they're both positive. This one is more determined by which either the X's or Y's, which one's negative, and that's going to go second because the negative has to be in between. Okay, next one says the foci are at 7, 1 and negative 3, 1, and the transverse axis is 8 units long. Okay, so right away, since this is saying that that's 8 units long, half of that is going to be the distance of one of the A's. So I can determine right away that A equals 4, even without graphing anything. However, we should probably graph the foci just to determine which way it's going. And let's see, the foci 7, 1. So if I go out here to 7, 1 and negative 3, 1. Okay, that's going to be a distance of 10, which means that my center is going to be in between. It's right there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. So my center would be at 2, 1. Okay. And let's see, the foci then. Well, to find this, first off, the A is 4. So again, from my center, if I go 4 in each direction along that same transverse axis, it'll be there and there. So this one looks pretty similar to the last one, actually, where our A is going to be 4, our C value is 5. So if I go A squared plus B squared equals C squared, this would be A, we said is 4, so 16. We don't know B squared. And then C squared is 5, so 25. Or C is 5, so C squared is 25. Subtract 16 on both sides, B squared equals 9, and we'll use that later. Okay, and I think I have enough now to write my equation. This is one where the x's would come first. Oops, I didn't draw that other one. I should go through this point. Okay, eventually it's going to look something like that. There we go. And so it kind of makes an X shape, so we know the x's come first. And if I jot this one out, it's going to be x minus my x value of the center, which is 2, quantity squared, over A is 4, so A squared is 16, minus, y minus 1, quantity squared, over B squared was 9, equals 1. Did I square them in the last one? Oh my goodness, I did not. So guys, in the last problem, these should be squared. I was just thinking about that. Those quantities need to be squared on the tops of your fractions. So if you didn't switch that back in bagger number 1, make sure you have those switched. Okay, let's try another one here. This says a vertex is at 4, 5. And the center is at 4, 2. So they give us the HK right off the bat. That's nice. Nice to know. And the equation of one asymptote is 4y plus 4 equals 3x. So sometimes these can be a bit tricky when they give us the equations, but we'll see if we can figure it out. First off, let's graph what we know. We know the center is at 4, 2. That's my center. And one of the vertex is at 4, 5. So what does that do for me? That tells me this is going to open up and down, so the y's will go first in this one. Okay, I can put the other vertex on if I want. That'd be down 3 in the opposite direction. And then it says the equation of one asymptote is 4y plus 4 equals 3x. So we want to solve for y in this equation. And you can do it a few different ways. What if, let's see, move that over. Let's see what happens if I do this. What if I take out a 4 and get y plus 1? Is this going to help me at all? Equals 3x. And if I divide by 4, I'm probably making this more complicated than I have to be. Over 3/4 x, and then if I subtract 1, get it into slope-intercept form here. Remember we talked about slope-intercept form last semester. Okay, so then at -1 is where I would start on my y-axis, and then this says to go up 3 and over 4. So it's going to go, that's going to be the corner, right? Up 3 over 4, 1, 2, 3, 4, the corner of that box. So if I outline this box, then it would look like this. Okay, and why is it important to put this box on? Well, that's going to show me where my B's are. Remember, the B's are perpendicular, so here and here, perpendicular to my transverse axis. This is the conjugate axis. All right, and then that should be enough to tell me the equation. In the equation, since B is 4 here, 4 units, and A we said was 3, we should be able to figure out what the equation is. And my center is at 4, 2, and the since this is one where it's going to open this way, those are my vertices, the y's have to come first. All right, so it's going to be y minus 2 quantities squared, better square it this time, over the a value, which we said was 3, so 3 squared is 9, minus x minus 4, that's for my h, quantity squared, over the b value we said was 4, 4 squared is 16, equals 1. Okay, so this one, that box really helps you when you draw that out. Next one says write the equation of a hyperbola with center at -2, -4. Let's graph that. -2, -4 would be down here is my center, my h and k. And it says there's a focus at 2, -4. 2, -4. And eccentricity, here we go, eccentricity of 4 over 3. Remember, that's going to be c over a, e equals c over a from our first slide. So c, it tells us right away, c equals 4, a equals 3. All right, what does this do for me? So my center, my eccentricity, let's use these values right away to find our b squared. All right, if we have a squared plus b squared equals c squared, fill those in. This is going to be 9 plus b squared, to 9, equals c, 4 to 16, okay? Subtract 9 on both sides, 16 minus 9 is 7, so b squared equals 7. And then the a squared from earlier was 9. I'm just going to write that down too. Okay, so we have to use those, and we already have our center. We know since the center and the foci are along this line, that's going to open up, so it's x's. Again, this probably isn't very right or very accurate, but it's going to open up that way somehow. So the x's have to come first. I think that's enough to write our equation. Let's try it. X minus our h, which is minus a -2 or plus 2, quantity squared, over our a squared, we said was 9, I think it's a 9, minus y plus 4, y minus a -4, quantity squared, over b squared is 7, equals 1. So it is enough to write the equation, and you get something like that. All right, that's it, guys. If you have to rewind or rewatch or go back, slow down, or whatever you need to do, make sure you get these notes taken. And then we do have a worksheet that will be posted on Google Classroom as the 11.4 day 2. See you guys next time.